In order to control the environment as we start our investigation, we must understand the environment. Here, digital evidence is being stored, created, and accessed. In most cases, this will be a computer system. I use the term computer system, and what that compromises is the operating system, the file system, and the hardware bundled together to create a computer. So, to be effective, you must understand the physical media the data is stored on. So, the file system used on the storage device and how that data is tracked and accessed while on the storage device. Once you understand the process, you can then implement controls to protect the integrity of the digital evidence. So, what is the boot process? Well, when you push the power button and electricity energizes the system, a series of commands is used. So as it executes the commands, the system is taking steps, just like on a ladder, to achieve the goal of a running operating system. So if something breaks any of these steps, then system will not load. So it will fail. So we have a post here. So what is the boot process? The first step is the boot process is the power on self-test post here. So this, in post phase, the CPU will access the read-only memory, ROM, and the basic input-output system, and the test to test essential motherboard functions. So actually, it's I will share this file with you um, after this lecture in assignments, or I will create separate lecture for sharing these files. So I want to write that everything clearly here. So when you look at it, you can understand easily. So this is the CPU will access here. Actually, let's make it bigger and text. CPU will access the read read only memory memory. So this is the ROM here, and the basic input output system, which in this case this is the BIOS. Actually, you know already, I think the BIOS is the when you enters with F4 F20 or F2 like tail buttons to boot device here. So this is where you hear the beep sound when you turn the power on the computer system. So this beep sound is not using anymore. This beep sound is the old computers using this beep sound. If there's an error, then system will notify you of the error on the computer through the use of the beep codes. Like if you have an like RAM error, this be will this motherboard buzzer will beep 3 times, "Teet, teet, teet," like that. So if there's an error, you will know about that. So for example, you can search these beeps in Google, and you will get the relevant result. Because if your video card is broken or something not working, you can see on these errors, or show BIOS motherboard cannot show these errors on screen, right? So instead of that, the motherboard uses the uh, buzzer to beep several times for searching and finding what's what's wrong with the your computer. So once the post test has successfully completed, the BIOS is activated and executed. Note that the system has not accessed the storage media for now uh, at this phase of our booting process. All the program executions are taking place at the motherboard level and not in the storage devices. The user can access the BIOS by using the correct key combination as displayed in the screen. So the BIOS then will have the basic information of the system, the amount of RAM, the type of CPU, information about attached devices, and system date and time. The easiest way to document this information is to take photograph of it as it displayed on the screen. So this is also where you can change the boot sequence. So typically the system checks the CD DVD first and then the designed designated hard drive. So this where you will able to change the setting of the boot device when we create the boot. Maybe later on these lectures, changing the boot device tells the BIOS to access the device we are providing and not the suspects. So in 2010, the BIOS function was replaced by the United Extensible Firmware Interface. This is the UEFI. I think you know that already. Actually, let's United. This is the UEFI. So, this United Extensible Firmware Interface provides the same service as the BIOS, but this is the like version 2 of the BIOS. So this is then enhanced. Like what's the difference? There's actually let's make uh, differences here. So actually, I want to delete that. Actually, I will write these differences down because I'm uh, searching for the right table for that. So, so as I said earlier, in BIOS had update, so by it actually replaced by UEFI, United Extensible Firmware Interface. Um, Actually, let me note that down here. Extensible firmware here. So it provides the same services as the BIOS, but has been enhanced. Like it has the better security at pre-boot process. It has the faster startup compared to BIOS. It has the support storage storage drives that larger than 2000 gigabytes, like 2 terabytes. Support for 64-bit device drivers, and this has the support for GPT partition tables. So the secure boot feature allows us to use authenticated operating systems when booting the computer system. So this can be unusual if you are attempting to use an alternative booting device. So um, let me actually make another diagram here. This is the power, this is the post. post, a post actually, let's make bigger words. And then we have BIOS and E here. Here comes, and this comes here. So as you can see in this diagram, actually, yes, you can you can see here. Once the power is turned on, um, and has completed the post test here, depending on the system, it may boot for BIOS or it may boot with UEFI theme. So the BIOS will look for the master boot record of the boot device. So BIOS will MBR is the just typical for BIOS here. MBR. So the MBR located at sector 0 and holds information about the partitions. So yes, so MBR holds the information about partitions. So so MBR holds the information about partitions, and also it holds information also file system and the bootloader code for installed operating system. So once the MBR found at the bootloader here and has been activated, control is then passed over to the operating system to complete the boot process. So the operating system for completing the boot process here, operating system. So after operating system, the computer is started and you can use a computer like. So then let's go to UEFI. So the UEFI United Extensible Firmware Interface, as you can see here, is enhanced version of BIOS. So UEFI will look for the GPT. So as you know, GPT is the GUID partition table. We will talk about it later. Then let's create a new here. So if I will look for the GPT, actually it's right, right, GPT here. So GPT will have a protective MBR to ensure legacy systems will not mistakenly read this as being on partition and then overwrite the data. It will also contain the partition entries and backup partition table header. So a GPT disk can contain up to 128 partitions. Yes, GPT disk can contain up to 128 partitions for Windows operating system. Just like the BIOS SIM, once the active partition and the bootloader have been found, the operating system will take over the booting process here. So since you know understand the boot process, we still want to control the boot environment with creation of forensics boot media, which we will discuss in next lecture. So I'm waiting you in next lecture. Actually, we will have a little test after this, actual practice test after this lecture. So I'm sure you can make and complete by 100% of these practice tests. So after completing the practice test, I'm waiting you in next lecture. Thank you for watching.